In this video, we're going to look at the electrolysis of aqueous solutions. So an aqueous solution is just a solution of something dissolved in water. If you take a look at the example on the right-hand side, we have sodium chloride dissolved in water. And as expected, you can see that sodium, because it's a metal, forms a positive ion, and chlorine, because it's a non-metal, forms a negative ion, and that goes back to the bonding topic. Sodium chloride contains sodium cations and chloride anions. Remember, the word cation is the technical word for a positive ion, and anion is the technical word for a negative ion. You can remember that because cation contains the letter T, and that looks a bit like a positive charge. This is a complicated situation. And the reason it's complicated is because water, as well as the sodium ions and chloride ions, also naturally contains a few H+ ions and OH- ions. An H+ ion is just called a hydrogen ion, and an OH- ion is called a hydroxide ion. And the presence of these four ions in the diagram on the right-hand side makes the electrolysis of aqueous solutions a little bit more complicated. Now, the fact that water contains ions naturally anyway should not come as a surprise, because you know, for example, in the kitchen, you have to be very careful with water and electrical appliances. So you are aware that water, under certain circumstances, can be an electrical conductor. Okay, and the reason for that is because it contains ions that can move. So this is the strategy that we're going to use. You need to remember a flowchart. So if you are asked about the positive electrode, what happens at the positive electrode? What is the half equation at the positive electrode? The question you need to ask yourself is the negative ion a compound ion? Now, a compound ion is something like nitrate, carbonate, or sulfate. If the answer is no, then the half equation is exactly the same as we would have had for a molten ionic substance. But instead of having the liquid state symbol, we now have an AQ state symbol. If the answer is yes, it's even simpler. You just memorize this half equation here. Remember, a half equation is just a balanced equation that contains an electron, E-. So you just remember that equation there. Now, even although that equation is on the syllabus, it's quite unlikely that you'll be asked to write the entire thing. Okay, much more likely the exam question will ask something like, what gas will be produced? And the answer would be O2 gas, oxygen gas. Another common question would be to give you this equation and say, add some numbers to balance this equation, add some stoichiometric coefficients to balance this equation. So that's what happens at the positive electrode. Now the negative electrode. If you're asked a question about the negative electrode, you need to ask yourself, is the positive ion in group 1? So remember, group 1 of the periodic table is lithium all the way down to francium. If the answer is no, then the half equation is exactly the same as we did for the molten situation. But instead of having a liquid state symbol, you now have an AQ state symbol. If the answer is yes, again, it's even simpler. you just memorize that half equation. Once again, in the exam, it's less likely that they're going to ask you just to write that out. Much more likely they'll ask you something like, what gas is produced? Hydrogen gas. Or, here's an equation, balance it. Okay, now this half equation is slightly easier than the one on the previous slide. And I believe students have on occasions been asked to write that out. Okay, so I don't think that's an unreasonable question for them to ask. Let's now have a look at some examples. Now, there are 3 common examples that come up in the exam, and we're going to go through all 3 of them, looking at the positive electrode and the negative electrode in each case. Let's have a look at sodium chloride solution. So we've got sodium ions and chloride ions dissolved in water. As expected, sodium, being a metal, forms a positive ion. Chlorine, being a non-metal, forms a negative ion. Part A. What is the half equation at the positive electrode? Okay, the positive electrode. So what we're doing is we're going back to this flow chart here, and we're working our way through this flow chart. So, the question we need to ask ourselves is, what is attracted to the positive electrode? Well, remember, opposites attract. So the negative ion will be attracted to the positive electrode. The next question. Is the negative ion a compound ion? So a compound ion, remember, is something complicated, like nitrate, sulfate, or carbonate. And the answer in this case is no. Okay, chloride is not a compound ion. So if you follow the flow diagram, the half equation is exactly as we would have had in the molten situation. But instead of having a liquid on the left-hand side, we now have AQ, which stands for aqueous, which means dissolved in water. Okay, next part. What is the half equation at the negative electrode? Okay, a very similar set of reasoning. Once again, we're looking at the flow diagram from before. So the negative electrode is going to attract the positive ion. Remember, opposites attract. We now ask ourselves, is the positive ion in group 1? Well, if you look at the periodic table, sodium is in group 1. So the answer is yes. And if you look back at the flow diagram on the previous slide, it's really straightforward. You just write out that half equation. And that is that question answered. Okay. Example 2. Copper sulfate solution. Okay. So once again, we've got copper sulfate, AQ, which means copper sulfate dissolved in water. And if you look at the diagram on the right-hand side, this is the situation that we have. So we've got copper 2+ ions. Copper, being a metal, forms positive ions. And we've got sulfate ions. Okay, so sulfate is, remember, a compound ion. It's one of the ones that you need to remember. SO4 2-. And water, as we said, naturally contains hydroxide ions, OH-, and hydrogen ions, H+. So what is the half equation at the positive electrode? Well, negative ions are going to be attracted to the positive electrode. Opposites attract. Do we have a negative ion that is a compound ion? The answer is yes. We're dealing with sulfate. So in this situation, you just write out that equation that I showed you. Okay, you don't need to understand where it came from, you just need to remember it and write it down. Remember, as I say, in the exam, even although it's on the specification, it is a little bit difficult writing that out from scratch. Much more likely, they'll just ask you what gas is produced, or they'll ask you to balance that equation. What is the half equation at the negative electrode? Okay, so positive ions are attracted to the negative electrode, opposites attract. Do I have a positive ion present that is in group 1? Look at the periodic table. Copper is not a member of group 1, so the answer is no. So in this situation, it's exactly as we would have had in the molten situation, but with an AQ on the left-hand side instead of liquid. And that is that question answered. Final example. Sulphuric acid solution, H2SO4AQ. Sulphuric acid is just a formula that you need to remember, H2SO4. If you look at the diagram on the right-hand side, these are the ions present. Notice that I only have 3 ions this time because H+ is present both in sulphuric acid and is found naturally in water. So we only have 3 ions this time. So the half equation at the positive electrode, well, negative ions are attracted to the positive electrode, opposites attract. Do I have a negative ion that is a compound ion? The answer is yes. Sulfate is a compound ion. And so you just write out that equation from memory. The half equation at the negative electrode. Well, positive ions are attracted to the negative electrode. Opposites attract. Do I have a positive ion that is a member of group 1? Take a look at the periodic table. The answer is no, we don't have a positive ion that's a member of group 1. So you would write out the equation that you would expect to have from the molten situation. Okay, so I've only got 1 positive ion there, it's hydrogen. And instead of having a liquid on the left-hand side, we now have an AQ.